O du mein holder Abendstern.
One of the things we do in math is study how to break down complicated things into simple parts to understand where subtle nuances come from. Here's a subtle nuance about music. If I play the same note on different instruments, it has the same frequency, but has a different sound to it, a different timbre. Here's a D on the piano. Here's a D on the violin. Here's me singing a D. La. Here's me singing a D not so nicely. La. We can tell that those sound different even though they have the same pitch. The pitch of a note comes from its frequency. Here's a picture of a sine wave, but most notes aren't perfect sine waves unless they're made by a computer. The timbre of a note comes from the shape it has rather than just its frequency. If I sing into this oscilloscope, we can see what shape of sound I make. Ooh. It's not a perfect sine wave. I can get quite close, but it's still not a perfect wave. Ooh. There's a branch of math called Fourier Analysis, which tells us how we can add together different sine waves to make funnier shapes of wave. Apps like this can analyze sounds to see what sine waves they're made up from. For example, ooh, that's me singing a D. D on the piano makes quite a different shape. Here's D on the violin. There's a branch of math called Fourier Analysis, which studies how we can build up funny shaped waves from adding different sine waves together. A computer can help us see how to add different sine waves together to make different shapes. Here's a picture of a sine wave. Here's a picture of sine x plus sine 2x. Here's a picture of 3 sine x plus sine 3x. Different vowel sounds have different shaped waves, and they come from the different combination of upper harmonics that we're using in our voice. A, E, I, O, U. Those are called overtones, and classical singers develop control over the upper overtones in their voice, which gives their voices more resonance. I can try and sing some overtones, but they might not be very loud. You can just about hear it whistling. That's the note I'm singing, and the harmonics are whistling around here. Sometimes contemporary composers use those overtones as special effects. And here is a clip of a contemporary composer who's also singing his own piece with very, very loud overtones. I'm pretty sure that singers don't think about Fourier analysis while they're singing. But you can be doing math even when you don't realize you're doing it.